All right. Now, you may have been told back in the day of geometry, there were 5 methods to prove triangles congruent. Side, 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 angle, angle, side, angle, and then in a right angle, in a right triangle, HL. By the way, this is a side, side angle situation. Well, it turns out that that's not entirely true. That there are some cases of side, side angle that aren't right angles that actually work. The problem is these 5 methods always work. Always, always, always. Hence the theorem. It is never disproven. Side angle, however, is one of those things where it could be something else, so we can't say for certain. The best we could say is maybe, okay? So theorems usually aren't about maybe. Theorems and postulates are usually about something we definitely know. Okay, so what we're going to look at is what's called the ambiguous SSA case, side angle. So that means the angle is not included. It's not included between the two sides. All right, so let's look at this diagram, this situation, and we are going to draw a diagram to the best of our ability, or diagrams. So let's see here. In example 3, triangle blah, 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 please fix that, ABC. AB is 8, BC is 6, and the measure of angle A is 35 degrees. So we're going to find all possible values of measure of angle C to the nearest degree. So let's attempt to draw this to the best of our ability. AB is 8. AB is 8, like so. I also know that angle A is 35 degrees, which is kind of small, so I'll go like this, and that's 35 degrees there. And lastly, BC is 6. So here's the situation. C is down here somewhere, okay? Now watch this, and I'll unpack it momentarily. Notice what this could be right here. That becomes 6 right there. Or it might swing the other way to go there and be 6. So do we see that this guy right here could actually hinge in 2 directions? It could go 6 this way or 6 this way. And no matter what, AB is still 8, and this degree is still 35. So the 2 possible diagrams look like this. So here is A and C somewhere over here. And if this is 8, like so, then this one is my 6. However, like I said, if I took this blue side and let it swing out like so, my other diagram is almost exactly the same. So here's 8, here's A, here's B. Again, that's still 35 degrees in here. But instead of letting the blue come inward, the blue is going outward to there. And that's my 6 there. So all we did was swing that over. Okay, now because of that, when we solve this, we're going to have to consider the 2 possible situations. Either this angle right here is obtuse, or it's acute. Obtuse or acute. So we're going to take a gander at that. So I do have to try to find out the measure of angle C. So the measure of angle C, and I'll do sine. So sine of C is over the 8. And notice that the 35 is opposite the 6. So there's my setup there. Continuing on, remember that the sine of C is equal to, I'm going to multiply these and divide that. So 8 times the sine of 35 divided by 6. After we figure out what this is, we have to inverse sine. So the sine of C is approximately 0.7648. And the reason I left so much space right there is because I do need to do inverse of sine and inverse of sine. So that means the measure of angle C is going to be approximately. Okay, now that's one possible situation. That would be clearly in this situation right there, 49.9 degrees. So the measure of angle C could be 49.9 degrees. And here's how you find the other option. The other option is simply the supplement. So the measure of angle C could also be 130.1 degrees. And let's just pause to think, are these both options reasonable? Well, notice here, remember that in a triangle, the three angles cannot be more than 180. In fact, they have to be exactly 180. So in this case, 35 plus the 130, it gives me 165, which means the remainder is a small one here. 35 plus the near 50 right there still means I have nearly 100 degrees up there. So yes, both of these are options, and both of these are logically possible. So that's why it's ambiguous, because we don't know if this C is going to be obtuse or acute. It doesn't tell me, so we're just going to have to check. And I did mess up. It says nearest degree, so this should go to 50, and that should go to 30. When I set things up, I like to just be very generic to start off. I'm going to intentionally make this without getting too crazy. I just made a random triangle. I'm going to label, remember, the angle Y measures 60 degrees, which is not 60. I didn't make it to scale yet. Opposite that would be my Y, which is 5. And then opposite the Z should be 3. Now that I have this information, let me go ahead and redraw things. Because look, this 3 should be a little bit bigger than half of this, however long this is. This 60 should look 60. So if I did X here and Y here, and this one has to be 3, now I need to make this angle 60 right there. So roughly 60 like so. I haven't extended it. I don't know where that's going to go yet. But I do know, I don't know the angle right here. I don't know the angle right here. So the angle, it could be obtuse. It could be whatever. I don't know. It just has to be a 5. So I have to make it so that this guy, which is 60 degrees, and it's on a trajectory to go this way. In fact, I could just keep going with it like so. That I need to make this thing length 5. I can't go 5 this way, right? Because if I do go this way, 5 has to be over here. So it can't be there because that's too small. Can't be there, too small. Can't be there because that would make it like a 3, right? So I got to keep going until it's roughly looking like a 5 to me, which to me looks about here. Okay? So that's the 5, and that would be my Z. So it takes some guessing to get it right. Now I can do the setup. So here's our setup. Now, again, with your calculator, all you have to do is multiply these, divide this, and then inverse sine. So once you set it up, folks, I do not need to see more work. This is your work, the setup. From there, if the intermediate steps are helpful to you, word to your grandmother. Otherwise, just plug all that stuff, multiply this way, divide this way, and inverse sine to get your measure of angle Z. So I round this to 31.3 degrees. And of course, remember in the ambiguous situation, I needed to supplement to see if it makes sense, right? So I'm going to supplement this to see what I get. When you supplement this, you end up getting approximately. Now here's why this one won't work, logically speaking. Remember that the triangle sum theorem says all three angles need to sum to 180? Well, if this were 31 degrees, then adding it to here gives you 91 degrees, which means this is 80-something degrees. However, if I take the 148 here, which clearly it doesn't even look at, 148 means that this one would be 208 when you added them together, which means we're already overdoing it. So this one has to be the case. So here would be a case where side-side angle produces exactly one situation. Okay, so just by way of review, sometimes side-side angle will produce one triangle, two triangles, or zero triangles. You might not get any triangle at all. So while you're working on your assignment tonight, you will find out that a triangle can't even be formed. In that case, if a triangle can't be formed, then we can't solve anything. So here are some things to consider when we're solving a triangle. First off, what even does it mean to solve a triangle? Just to find all 6 missing parts, right? Find all 6 measures. That is the measures of the 3 angles and the measures of the 3 sides. So what are some things to consider? Number 1 is, please use the triangle sum theorem when you can. Triangle sum theorem. So all 3 angles sum, the 3 angles sum to 180. And more specifically, the 3 interior angles of a triangle sum to 180. Another tool is that if you have a right triangle, we've got Pythagorean theorem. We also have trig ratios to use, SOHCAHTOA in other words. So those are helpful. We also have law of sines. And let's see, when can we use the law of sines? And when can we use the law of cosines? So the law of cosines requires side angle side or side side side. Law of sines best works when you have 2 angles. Angle angle side angle. But notice that we also put in sometimes side side angle. And this is the ambiguous case.